Hello there, everyone. My name is Crazy Caleb, and today we are not taking a look at the witness, we're not taking a look at Boolean keypad, we're not taking a look at odd one out, but instead we are rather taking a look at this boss module here, Forget Us Not. So the way how this module works, and the way how this module looks, is actually rather quite similar to the first boss module of Forget Me Not. However, the difference between these two can be discerned very easily. Forget Me Not has a stage counter up in the top right, and Forget Us Not does not, essentially. So, the question's got to be asked, how do you know which stages you're recording? Well, thanks to the bottom display, you will be recording different stages. But what exactly are you recording, per se? So we have stage 8 here, and whichever normal module we solve next, that is what we will put down for stage 8. So for example, if I were to solve probing next, that would be stage 8. So let's start solving some stuff. And we'll start recording modules, and what we're going to do at the end of this is do a whole bunch of calculations regarding 3-digit codes you get from each module. And I am quite frankly sure that all of these have codes, because they're all old enough. And since this module does not keep up to date with every single new module, if that module does not exist, it can be put down as any other module not listed on these several columns of lists of modules here. So now, let's take a look. So we're going to start off with stage 8, and just as an FYI, I am using this little logging module. This logging module is made by Emic, so thank you for making that. And what we're going to do is I'm just going to go through each log and start solving some stuff, because that's all I really have to do in order to demonstrate how this module works. So, let's take a look. Let's start off with Boolean keypad. So let's take a look here. Button 1, we're going to press that. Button 2, we're going to press buttons 1 and 4, while noting down that we will solve Boolean keypad for stage 8. So 1 and 4. And next up will be stage 3. So let's solve something for stage 3. Let's do Simon's star. And note that this module can be solved itself. So let's just go next past all 3 pages. Solve logging. Yes, it does make that sound. And that's how logging works. So that's how you can solve that module. Just go past all 3 pages. Next up, let's take a look at stage 9. And it is good to note that also, when you do solve logging, you can still view everything in here. So that's perfect. Let's go to Simon's star. And now what we're going to do is we're going to press green, then green, blue, then green, purple, yellow. Exactly. So, green, green, blue, and green, blue, green, and green, blue, green, purple, green, blue, green, purple, and green, blue, green, purple, yellow. That would be Simon star. Just confirm that we're recording. Yes, we are. Next up is going to be stage 6. And now, let's start taking a look at some other stuff. I'm probably going to have to do 3D tunnels on its own because there's no logging for that, so you're going to get to watch me struggle with that. But for now, what we're going to do, I'm going to do snowflakes. Okay, so snowflakes does have to be also solved with the manual. So, currently week 18, so go to Echo 2, starting in Kilo 4. A, B, C, D, E, 2, we're going there, and Kilo 4. E, F, G, H, I, J, K, 1, 2, 3, 4. Just make sure that that's right. Yes, it is. Okay. So we're going to be solving snowflakes for 6. Let's write that down. Let's go up, right, up, left, left, up, down, left, left, up, left, 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 down. Wait for the submission. Solve module. Next up is going to be stage 1. Let's do the witness. Witness is a nice solo for me. Excuse me. All right, let's do the witness. Next up will be stage 5. Let's do a type racer, perhaps. Back. Type racer. The correct word is welfare. Okay. Welfare. A, an R, and an E. That would be type racer. Next up will be stage 4. Let's do 3D tunnels. Let's get this done with. Okay, that actually is a pretty good spot. Left, Microsoft key, up. I have a pretty good idea of where I'm looking. Like that. That makes sense. So, up, right, submit. For the ribbon. Where exactly is the ribbon? I see it. Okay. Right. Back up there. Up, left, submit. Left. Up. Yep, and then right. So we'll do 3D tunnels for 4. So 3D tunnels. Next up is going to be stage 10. 3D tunnels is done. Next up is going to be, let's do odd one out. So let's take a look at odd one out. So that'll be top right. Next up will be top left. Next up will be bottom middle. Next up will be another bottom middle. And lastly, top middle. And our last button to press will be bottom middle. Alrighty, next up is stage 2. Last 2 modules we have is probing and festive piano keys. Let's do festive piano keys. Let's take a look at this. Festive piano keys. Alright, 7 times G, excuse me. Alpha sharp, delta sharp, foxtrot golf. Alpha sharp. Festive piano keys. And lastly, stage 7, as we expected, probing. So now for probing, I'm just going to do this one in manual because it's a lot easier that way. One. Oops, that's not what I want to do. Number 1 is missing a 6. Okay. Connect missing 5. Alright, that works. Number 5 missing 1. Otherwise connect missing 6. That works right there. Give it a second to submit. And now it wants an input. So now let's actually figure out how exactly this module works. And the information that we need is the serial number. So we have an X-ray November 7, Delta Tango 1, and the battery count as well. In this case, we have 1 and 1, or just 1. So now what we need to do is we're going to be taking a look at how this module works. And the very first thing I'm going to do is I'm going to grab each of these modules' 3-digit codes. So we're going to search up the witness. That'll be 656. Next up, we'll do festive piano keys. 144. Logging should not be present, so that's going to be a 998. 3D tunnels should most definitely be present. 3D tunnels is a 309. Type racer should be present. 792. Snowflakes. 951. Probing. 850. Boolean keypad. 015. Simon star will be a 774, and odd one out will be a 243. So now we have all of our 3-digit codes gathered here. So now what we need to do is take a look at this step 1 first. So step 1 wants us to use the edge work on the bomb to determine which of the following conditions applies for our forget us not modules. If you reach a negative number after applying the offset, drop the negative sign and act like it doesn't exist. So if the serial number contains 4 letters and 2 numbers, let's check. It contains 4 letters and 2 numbers. Yes, this will be our case. So what we're going to do is we're going to subtract the number of batteries on the bomb from the first digit of the 3-digit number you obtained from Appendix A. So what this means is that we're going to essentially subtract 1 from each of the first 100 digit, essentially. And the way how this works with the rest of these, it's the same battery rule, but with the second digit for 3 letters and 3 numbers, and the third digit with 2 letters and 4 numbers. So in this case, we subtract 1 from each of our first digits here. 6 minus 1 is 5, 1 minus 1 is 0, 9 minus 1 is 8, 3 minus 1 is 2, 7 minus 1 is 6, 9 minus 1 is an 8, 8 minus 1 is a 7, 0 minus 1 is negative 1, but as we've said here, if you reach a negative number, after applying the offset, drop the negative, so that 0 will become a 1. 7 minus 1 is 6, and 2 minus 1 is 1. So that's the first step taken care of. Next, what we're going to do is we're going to take the other 2 digits that you did not alter in the third digit number obtained and subtract the least significant from the most significant. If this operation yields a negative, drop the negative sign like before. So what we're going to do is it's going to be the second digit in this case, and these are going to be doing the other 2 digits that we did not use from the first step. It'll be the leftmost subtracting. It'll be the leftmost subtracting the rightmost. So essentially, what we have here is 5 minus 6. So that's negative 1. So 1. 4 minus 4 is 0. 9 minus 8 is 1. 0 minus 9 is 9, which in this case would be negative 9, but we drop the negative sign, so negative, so that'll be 9. 9 minus 2 is 7. 5 minus 1 is 4. 5 minus 0 is 5. 1 minus 5 is negative 4, dropping negative sign, being 4. 7 minus 4 is 3. 4 minus 3 is 1. And lastly, add the result from step 1, being the first digit that we subtracted with the batteries from, and take the least significant digit if the sum exceeds 9. So essentially just mod 10. So we're going to add 5 plus 1, in this case being 6, 0 plus 0 being 0, 8 plus 1 being 9, 2 plus 9 being 11, so 1, 6 plus 7 being 13, so 3, 8 plus 4 being 12, so 2, 5 plus 7 being 12, so 2, 4 plus 1 being 5, 6 plus 3 is 9, and 1 plus 1 is 2. And this is our calculated number for each stage. So we're going to enter in 609, 132, 259, 2. 609, 132, 259, 2. And just like that, that's how the module works. So what this means is that we figure out which number to subtract the batteries from. We leave that number alone, and then we subtract the most significant. It'll be most significant minus least significant digit. And what we're going to do after that result happens, we're going to add the digit that we subtracted the number of batteries from to our result from step 2. It's rather quite simple. Let's take a look at one final example. I won't do as many modules because you get the idea of how this works now, hopefully. And of course, if you have any questions, please don't be afraid to let me know in the comment section, because I don't want to be confusing anyone with this, and it's a very easy module to mess up, but once you get into a rhythm, it becomes very, very easy, I insist. So this time let's do 4 modules from a random pool, 1 logging and 1 forget stop. So 5 stages. Just to make it a little bit smaller and a little bit easier on me. And also because you probably get the idea now. We're still recording, we're doing good so far. Hopefully we can get a different example of the letters and numbers.
There is only one perfect solution.
Okay, not too bad.
Clues that will try to trick our team.
Okay, so the number of batteries we have is 2. We have 2 batteries, and we do actually get a different condition. Perfect. So in this case, we have 3 letters and 3 numbers in the serial number, along with 2 batteries. Not 3, 2 batteries. I can spell. There we go. And now we have a couple different modules that we're going to be working with here, and let's get to work. So stage 1 is our first stage. Let's start off with the code, for example. Let's do the code, and we will divide this display number by 20. So 9706 divided by 20, 485. Next up will be stage 4. Let's get logging done for why not. Next up will be stage 2. Let's do a module homework, which actually I don't believe is on the logging here. What I'm seeing, it's only page 1 of 1. Interesting. Nice, we actually get the solution. So let's do Kidoku. So we'll have 8 and 1 and then 6 and 2. 35974. 97. Next up will be stage 5. Let's do Widdershins. 7 places counterclockwise. 3, 4, 5, 6, 7. Clockwise. 1 clockwise. Stage 5 will be Widdershins. And stage 3 will be a module homework. Four clockwise from the current. 1, 2, 3, 4. And just like that, lastly we have stage 3. So let's actually pop up. Yeah, we have to actually pop up the true logging on this thing. Oh, no, it actually does pop up on activation. Okay. Button that must be pressed 3. Module homework. I can get that up quick enough. I don't know if I will. Let's take a look. Case number is 7. Homework is from high school. Button that must be pressed 3. 4. Bottom left. Yep. And now we have the submit. I didn't know if button 3 meant what it meant, but yeah. Okay, so now let's get all of our codes with this module. So let's search up the code. That'll be a 985. Kyudoku will be 678. Module homework 732. Logging, as we said before, it was not present, so we're just going to use any other module, in this case if it doesn't happen to pop up on the list, so 998. And it's also important to note also, in case if I didn't mention this already, the way that these modules are ordered with the list are the order of the release date. So it'll be all of the vanillas first on the top, then a whole bunch of Centurion modules, then like Praetorian, first 200 modules, But the way that these columns work is we have this first column here all the way down to colored squares. Then it goes next to adjacent letters. And then it goes next to algebra. So it'll be 3 columns, and then you'll have this little space that you'll be able to see there, and then it'll move down to there. So that's how this module works. So if you aren't able to control F for some reason, and you couldn't find the one that you're looking for, if you have an idea of the release date, you should be able to find it perfectly fine. And lastly, Widdershins. 450. So the way that this module works, so let's figure out now. So we have 3 letters and 3 numbers. Subtract the number of batteries on the bomb from the second digit in the 3-digit number. So in the middle. So we're going to be subtracting 2 from each of these numbers. Let's actually space these out, if that gives a little bit of a better of an illustration. So we're going to subtract 2 from each of these. 8 minus 2 is 6. 7 minus 2 is 5. 3 minus 2 is 1. 9 minus 2 is a 7. And 5 minus 2 is a 3. And now, as we did before, next take the other 2 digits you did not alter in the 3-digit number you obtained from Appendix A and subtract the least significant from the most significant. So in this case, it's going to be 9 minus 5, giving us 4. 6 minus 8 giving us negative 2, dropping the negative is 2. 7 minus 2 is 5, 9 minus 8 is a 1, and 4 minus 0 is a 4. And lastly, we add the digit we got from the battery calculations from the first step. 4 plus 6 is a 10, so 0. 5 plus 2 is a 7. 1 plus 5 is a 6. 1 plus 7 is an 8. And 4 plus 3 is a 7. So we're going to submit 07687. 07687. And just like that is a solved module. As always, I hope you guys enjoyed. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.